Chapter 6, Probability, Part 3, the Unit Normal Table. The proportion for only a few z-scores can be shown graphically on the following slide. The complete listing of z-scores and proportions is provided in the Unit Normal Table. The Unit Normal Table is provided in Appendix B, Table B.1. So we've already gone through a couple of examples in the previous video, but what proceeds is the sections of the appendix in the Unit Normal Table, so you know how to utilize it, how to enter it, and how to read it. So figure 6.6, proportion of the Unit Normal Table. So not proportion, portion, excuse me, of the Unit Normal Table. So here's just a brief section of the Unit Normal Table, and notice that there are headings here at the top, columns A, B, C, and D. And column A, if we're converting an x value into a z-score using our equation, z is equal to x minus mu divided by standard deviation, this is how we would enter the table. And we would look for the z value. Again, the z value is representing the distance a score is from the mean expressed in standard deviation units. So if we want to find out what is the proportion or percentage of scores below a value, above a value, between two values, we first need to convert the x value into a z-score. And then we have these different sections of a normal distribution. The body, as we have illustrated here. So here is a positive z-score, and I say positive because it's to the right of the mean. So the mean becomes a z-score of 0. So anything to the right means that it's positive. Anything to the left would mean it's negative. So this is the area we would refer to as the body for a positive z-score. It's always the larger area, and it always encompasses 50% of the distribution, right, half of the distribution, plus the area between the mean and the z, which is referred to as column D, the proportion between the mean and the z. Notice that I often say the area, and when I say the area, I'm using that synonymously with the word proportion, so I use them interchangeably, so I don't want you to get confused. So this is referred to as the area between the mean and the z, this area here, and is referred to as column D. So this is helpful to understand in regards to answering questions that may be looking for the proportion of scores below a positive z. And if it's below positive z, we know immediately that our final answer must be something greater than 50% because it includes half the distribution plus some. And knowing that and also shading the area of interest will ensure that you don't report the incorrect column when answering homework questions, quizzes, or items on the exam. Column C is referred to as the tail, and of course there are two tails in a normal distribution, but this is the tail in reference to a positive z-score. So similar to the example I walked you through in the previous video, we were looking for the proportion of SAT scores above the score of 700. This is how we would approach it. We would find the z-score and then shade to the right, which is the tail, the area above a particular value. In this case, a positive z-score. And then we have column D, which is the area between the mean and the z. So we have the mean in the center, and then here a positive z-score. And this area here is the area between the mean and the z, or again, the proportion between the mean and the z. Now I'd like to point out that each of these has an equivalent negative value. So if we have the mean in the center, and we're looking at a negative z-score, notice that the body now would be shaded to the right because now we have 50% here, and then the area that's referred to as the area between the mean and the z would be this area here. So just recognize how things change in terms of shading when we're looking at a value that's below the mean. So in this case, let's say we're considering the example of the SAT scores where the mean is 500, and we want to know the proportion of individuals that score above 400. So 400 would be less than 500, and we want to know those that are scoring above 400. So all the shading would occur to the right of the distribution. Similarly with the tail, we recognize that we can have an instance where we're talking about a negative z, and in this case we want to know the proportion of scores below this negative z. So it would be this area. And again, if this was 500 in reference to the SAT example, and this is 400, now we want to know the proportion of individuals that score below 400. And then finally, we can have an example of a negative z in reference to the area between the mean and the z. So the area or proportion between the mean and the z and the tail will always be proportions less than 50% because they make up half of the distribution. And if you look at any area between the mean and the z for any z-score, let's just take this one for instance, 0.34. The area in the tail added to the area between the mean and the z, if you take any column C and column D for a particular z-score, the summation of those two will always equal 50%, or a proportion of 0.5, because they're taking one section of the half and then the other section of the half. So just recognize that this is applicable to any z-score. And again, that's one of the characteristics of a normal distribution. 50% of scores below the median and 50% above the median. Figure 6.7, and I just noticed in our text and in this slide there is an error. This should be a positive 0.25 because it's to the right. So that's a typo. And as you will see, there are some typos in the text, which is very common in a math textbook. And when we do catch something like that, it's a learning opportunity. They're just typos, human error, computer error, but when we note them, it helps reinforce that you understand what you're looking at. So when I looked at this, I realized that this doesn't make sense. And in fact, here they're telling us we're working with a positive and negative z-score of 0.25. Anything to the right is going to be positive. And this particular slide demonstrates that if we're talking about a z-score above the mean, it's positive, and we would have the area of the tail here in white, and the body is always the larger area. Again, it always includes 50% plus this area here, which we refer to as the proportion between the mean and the z. Now, if we look at it in terms of a negative z-score, again, we have the tail here. Now it's on the left, and the body is on the right. And again, that is 50% plus this area, which is the area between the mean and the z-score. So just know that because of the characteristic of symmetry, because the normal distribution is symmetrical, these proportions are going to be equivalent, but just on the other side. So notice that these are equal and these are equal. And if you were to take any tail and body and add those together, what do you suppose that would equal? We talked about taking the area between the mean z and the tail, and that would always equal 0.5 or 50%. So if we took the tail and the body of any z-score, so in this case 0.4013 plus 0.5987, should see that it's equal to a proportion of 1 or 100%. So again, and the proportions will be identical. Now please don't make the mistake that many students make, and that is to report a proportion as a negative when we're working with values below the mean. This proportion here, the body of 0.05987, just because it's on the left side below the mean, does not mean that we would report a proportion of negative 0.5987. That would be incorrect. Again, the z-score can be negative because that's telling us the location below the mean, but the proportion would not be negative. It will always be reported as a positive number. So I want to warn you from making that mistake because it's very common. The proportions below the mean are never reported as negative proportions. Probability, proportion, and z-scores. So The unit normal table lists relationships between z-score locations and proportions in a normal distribution. If you know the z-score, you can look up the corresponding proportion. And again, to find the z-score, we know that we use our equation of z is equal to x minus mu divided by standard deviation. And once we know the z-score, we can enter column A of the unit normal table. If you know the proportion, you can use the table to find a specific z-score location. So this is working backwards, and I'll show you some examples of how to do that. Working in reverse, where we have other information other than the x value to find our z, we can, instead of using the z-score to enter column A, we're going to use the proportion and work backwards to find out what that z is equal to. In those instances, we're going to solve for x, which x is equal to the mu plus the product of the standard deviation multiplied by our z-score. And when we talk about probability, we should recognize that it's equivalent to proportion. So when we state something as a probability, the probability of an x value greater than 700 on the SAT, it's equivalent to finding the proportion of the distribution, the proportion meaning the section or the part of the whole that corresponds to these parameters. So the probability is equivalent to proportion, and then the proportion can always be converted into a percentage. Figure 6.8 refers and relates to examples 6.3a, B, and C on page 160. So in A, we are interested in determining what proportion of the normal distribution corresponds to z-score values greater than z equal to 1. So first you're going to identify where z of positive 1 would be located. It's positive, so it'd be to the right. And then, because we said greater, we know we're going to shade that blue area that's already shaded to the right. Okay, so at this point, we know that our final answer must be something less than 0.5 because it's a fraction of that half. And once we shade it in again, that will help us reconcile our final answer. To find the shaded area, you simply look for a z equal to 1 in column A of the unit normal table to find the corresponding proportion. So what we need to do, again, now we have our z value, so z is equal to 1.00. This area here that's been shaded is referred to as the tail. So let's enter a unit normal table and find that proportion. So here's that section of the unit normal table that is of interest to us. So column A is the z-score. Here is a z-score of 1.00. And we identified the area that we shaded as representative of the tail. And so here is the proportion of interest of 0.1587. So our initial question was, what was the proportion of this distribution above a z-score of 1.00? And we've just determined that this is representative of a proportion of 0.1587. We could have also stated this as a probability question. For instance, we could have asked, what is the probability of selecting a z-score greater than z equal to positive 1.00? So probability of selecting a z-score greater than 1.00. And our answer, again, would not change. The proportion is equal to 0.1587, or we could say the probability is a 15.87% chance. That there's a 15.87% chance that if we selected any score in a normal distribution, that score would be above a z-score of 1.00. In our next one, B, now we're interested in determining the probability of selecting a z-score less than a z equal to 1.5. And again, it is positive, so it's going to be to the right of the mean. In the area of interest, because of the word less than, we've shaded to the left, and so that blue area represents what we've stated, and we could write in a probability statement the probability of obtaining the z-score that is less than a positive 1.50. And our goal is to determine what proportion of the normal distribution corresponds to z-scores less than 1.50. So we're going to use the unit normal table to enter column A using 1.5. In this area, what do we refer to this area as? Is it the tail, is it the body, or is it the area between the mean and the z? If you answered the body, you're correct. The body is always the largest area and encompasses 50% of the distribution plus column the column that represents the area between the mean and the z, which is this area here. So now we can use our unit normal table to answer this probability statement. So here's that section of the unit normal table that's of interest to us. We use column A to enter column A, and we're looking for a z-score of 1.5, and there it is. And the area of interest was the body in this case because we shaded half of the distribution plus some. So this is the proportion of interest, 0.9332. So our response would be 0.9332, or we could say that there's a 93.32% chance that if we randomly selected a score from this distribution, that z-score would be less than a positive 1.5 or below 1.5 standard deviation units above the mean. So again, showing the difference of the tail and the body, we can contrast those. And again, stressing the importance of shading the area of interest, because if I would have reported the tail in this particular example, it would have been the difference between 1.00 and 0.9332 and give me a very small probability of proportion. And visually, it wouldn't make sense with this large area that I shaded, which is referred to as the body. And finally, example C. Many problems may require that you find proportions for negative scores. For example, what proportion of the normal distribution is contained in the tail beyond z equal to negative 0.5? This word beyond, you'll see often, and we often think of beyond as, at least I do, forward. But in our purposes of using the unit normal table and finding z-scores, beyond refers to the area in the tail, so don't always think of it as to the right, and this is a good example to point that out. So you may have something that says beyond a z-score of negative 0.5, and that is indicating that we're interested in, again, the location of negative 0.5, which has been placed for us on this distribution, and the blue area is to the left, and that is in relation to the area beyond. It's always the tail when we see the word beyond, whether it's the negative or positive side of the distribution. So again, we want to find out what this proportion of the distribution is equal to. So we're going to use our unit normal table to enter column A and report that specific proportion. But before we do that, what do you imagine your answer will be like? Do you expect it to be greater than 0.5, less than 0.5? If you said less than 0.5, you're correct, because again, this area, all this here, is equal to 50%, and we shaded a portion of that. So we know that our answer is going to be, and again, 50% is the same as 0.5. So we know the proportion that we're looking for must be something less than 0.5. And here's our unit normal table, column A, and our proportion. And this is by coincidence that all the ones I've been modeling are at the top. That's not always going to be the case. 0.5 is the z-score of interest, and then the tail was the area that was shaded, again, the area beyond. So our proportion is 0.3085. So this proportion is equal to 0.3085 or 30.85%. And again, is it less than 50? Yes. And that affirms that we did report the correct area of interest. And again, this one could have been written as a probability statement. What's the probability of randomly selecting a z-score that is less than negative 6.5. And here is our answer for that particular example. In the following example, we'll look at example 6.4a and b. And this process is a little different, and what we're going to use is the equation x is equal to our mu plus our standard deviation multiplied by z. Now, this particular example doesn't take us all the way to that point, but I just want to point out that if you are looking at this type of question where they're partitioning off a certain percentage in the tail or in the body or in the center, that ultimately that'll lead you to solving for x. But these are baby steps, and we're going to begin with just identifying what that z-score is, because that's what we would need in our equation. The other variables would be given, so these two would be given, and we'd want to solve for x. But this first step just requires us to identify what the z is. And so for a normal distribution, what z-score separates the top 10% from the remainder of the distribution? To answer this question, we have sketched a normal distribution and drawn a vertical line that separates the highest 10% approximately from the rest. The problem is to find the exact location of this line. In other words, identify what that z value is equal to. So in these types of problems, you do not shade, because we're not looking for the proportion that has been identified in terms of the top 10%. What we want to find is this value, the z value that corresponds to cutting the top 10% off and then separating it from the lower 90%. So if a problem identifies a percentage, to convert it into proportion, and we'll need to do that because the unit normal table is all lists of proportions. So we need to convert 10% into a proportion. So we divide by 100, and that's actually been done for us here. So we're looking for a proportion of 0.1000, and we see that that proportion is illustrated by the tail. Okay, so this is the tail. So that's how we're going to enter the unit normal table. So opposed to what we did in the previous examples, we entered column A, the z-score, because we had the z-score. But notice in this question, we want to find out what z is equal to. So we have to find a different way or a different route to access the unit normal table. So we found that. We are going to use 0.10 and find that in the column referred to as the tail. So here's the first page of the unit normal table, and again I'm entering not using A because that's what I'm trying to solve for, but I'm going to enter column C, and I'm just going to go down. I'm looking for 0.1, and again column C continues over here, and I'm looking here and it ends at 0.3121, obviously too high, so I'm going to go to the next page, and again using column C to locate 0.1. Go all the way down, still too large, and here we're getting a little closer, and we're looking for the closest proportion to 0.100. Now recognize that you're not going to find the exact value, but you report the closest to, and here we're very close, and I'm going to stop here, and the proportion of 0.1003 is an option, and 0.0985 is an option. But the rule of thumb is always go with the proportion that's closest to the one that you're looking for. So we would all agree that this is closer than this one. And therefore, what I want to report is the z-score. So the proportion of 10% in the top tail corresponds to a z value equal to 1.28. 1.28. So we've identified the z-score to equal 1.28. 1.28 standard deviation units above the mean cuts the distribution off where we have 10% of the distribution above that value and 90% below. And again, now that we have the z-score and we wanted to use it to solve for x, we now have everything we need to do so. Now, we could have approached this as, that was the top 10%. We could have looked at it as the bottom 90%. and we would arrive at the same answer. It's just a way of dissecting the distribution differently, looking at it from a different lens. But if the question says the top 10%, I would recommend just use the values that are given and convert that percentage to a proportion by dividing by 100 and utilizing the particular area of interest, whether it's the tail or the body that they've identified, given the terms top or bottom. Those are things to look for. Now for the next example, in a normal distribution, what z-score values form the boundaries that separate the middle 60% of the distribution from the rest of the score? So again, we've identified that area by partitioning off the center and represented as 60%, which is the equivalent of a proportion of 0.6. We just took 60, divide by 100, and we get 0.600. Now, is this a proportion that we're familiar with? In other words, is it the body, the tail, the area between the mean and the z? Well, it's none of those as it stands now. So we need to be creative in how we're going to solve this problem. And again, we've sketched out the distribution. We partitioned the middle 60% off in the center. And what we need to do is be able to utilize this so that we can focus on one of those areas, the tail, the area between the mean and the z, or the body of the distribution. And the best way to solve this is to recognize that if we divided this in half, right, by using the mean, now we have an area of interest, an area that we're familiar with. This is referred to as the proportion between the mean and z-score. And it's the same on this side as well. So if we take half, right, we split it in half, now we have a proportion 0.300 here and equally 0.300 here. So that allows us access into the unit normal table. So we're going to look for 0.3 in this column that's referred to as a proportion between the mean and the z. So again, this is the first page, and the proportion between the mean and the z is column D. And again, we're scouring for 0.3, and this is really far off, so we know that we can turn the page and continue. So column D, and we go down, and we're getting close. And here we are at the very bottom of this page, and there's a proportion 0.2995. which is the closest, because if we come back over here where it continues, this has gone way over. Again, our proportion of interest is 0.300. So now we identify that the z-score that corresponds to splitting the, or defining the middle 60%, and when we split that in half, the z-score of interest is equal to 0.84. And this is a good example to review because of the fact that we have a distribution that looked like this, right? We had 60% in the middle, and we want to find out what z is equal to here and z is equal to here. And we just said it's 0.84. That would correspond to the right side because that's a positive. And here on the left side, what do you suppose we would write? If you said negative 0.84, you are correct. Again, recognizing that column A is never going to report a z-score as a negative. It's a mirror image, so we don't need a whole distribution negative z-scores because we can just use the positive versions and understand that it's a mirror image on the left as it is on the right. So to answer this particular question, again, now we were asked to identify this value. So this is 0.84 negative and positive 0.84. So again, the original question was to determine what z-score values form the boundaries that separate the middle 60% of the distribution from the rest of the scores. Again, we identified that 60% in the middle was not a column that we could utilize in the unit normal table. We had to divide that in half, and what was left over gave us the proportion between the mean and the z. And again, in this case, we would use that equation of x is equal to mu plus standard deviation multiplied by z-score. The next step would be to identify what are the scores that center or separate the middle 60% of the distribution. Again, these would be given, and we would just have found out what the z-score is, and we know that we would solve this twice because we have a negative version of the z and a positive version of the z-score. All right, so let's review by engaging in the learning check. So find the proportion of the normal curve that corresponds to z is greater than 1.5. So always start with your distribution. Identify the mean. And this is a positive 1.5, so we know it's to the right, 1.5, and it says greater than. So I'm going to partition this off, and I'm going to shade this area. Now, given that shading, which answers can I automatically eliminate? Well, this one and this one, because I know that this is a fraction of the half of the distribution above the mean. And I'm left with these two, right, as possibilities because they're less than 0.5. And given the tail and the distance from the mean, you can probably guess which one it is, but let's go through the motions of identifying or finding the z-score and then reporting what we refer to as the tail to answer this specific question. And here's the unit normal table that includes a z-score of 1.5. The tail is 0.0668. So therefore, this is our answer. And again, going back to the drawing that I had provided, this idea of one standard deviation unit from the mean gives us the common scores. This is considered outside of that common region, so our initial guess should have been closer to this, opposed to this, because of this idea that it's further from the center. In other words, if we were talking about a value, a z-score of 0.5, right, that's half a standard deviation unit, then our guess would have been closer to this response because that area has increased as a result of this getting closer to the mean of the distribution. All right, true or false? For any negative z-score, the tail will be on the right-hand side. Well, let's draw this out. Do we have our distribution with the mean? We're working with a negative z-score, which would be on the left. And the tail, right, the tail would be this area. And that would be the left, right? The left, not the right-hand side. True or false? So this would be false. True or false? If you know the probability, you can find the corresponding z-score. Yes, that is true. We just went through examples of identifying the probability, which is the same as the proportion, right? Equal to or percentage. And we were able to identify the z-score that corresponded with a particular proportion of the distribution. And that is it for this part of the lecture for Chapter 6. And we'll continue with some more examples in subsequent videos.